Here's integrated 3. It's problem 8-78, letter C. So it's still asking us to find the equation of a function that has these roots. So now this next one, it's got 1, 2, 3 roots, so it's going to be a cubic. So how on earth do we do it when it's a cubic? So we do the same procedure. You're going to take each root and kind of like go x minus the root. So x minus -2, that's positive 2. X minus root 7 and x minus negative root 7. Okay, so these are the 3 factors that we need to multiply together. So I'm going to have to multiply 2 of them together and get an answer, and then multiply it by the third one. So I think it's easiest to multiply the conjugate pairs together because things are going to cancel out on them. So keep that in mind. So I'm going to do a little diamond problem just with this conjugate pair. Like I'm going to leave the x plus 2 alone, and I'm going to multiply these two together using an area model box. So I just write one of the factors along the top and you can do it along the bottom. I know you guys are used to that, and the side. And basically, x times x is x squared, x times -7, or negative root 7. I'm just multiplying. This one is a negative times a positive, so it's going to be a negative. Root 7 times root 7 would be just 7. And then these two cancel out. And so I come up with x squared minus 7, because x squared minus 7. And then I have to do it again, because it's going to be a cubic. So I'm going to multiply this binomial times this binomial, so I have to get another area model box out. And then I just go ahead and do the same exact procedure, multiplying them together, putting the answers in the box. And then when I write this answer down, I'm going to look inside and try to combine ones that go together, but you'll notice none of them go together. There's a cubed term, a squared term, and x term. So you just write them all down like that. See, I'm just grabbing them right out of the inside of the box right here. Okay. And then here's letter D. Whoa, letter D. So letter D, I think it's also going to be a cubic because it's got 1, 2, 3 roots. So it's got 2 complex roots and a real root. So we, again, just go x minus this, x minus this whole thing. That's why see the signs changed, and x minus this whole thing. And so now I have lots of stuff just to multiply together. I have 3 factors to multiply together. The easiest way is to take the complex ones. They're sort of conjugates of each other, so you want to multiply those together first. So I'll leave this x minus 4 alone, and then I want to multiply these together, so I'm going to grab an area model box to do that. And I just write this, and then I write this on the side. X times x is x squared. Hopefully you get the idea. It gets a little gnarly because, you have to keep track of what you're doing. Hopefully you don't make any mistakes. And then you go ahead and go through here, and I'm going to go through and find the ones that I can combine together. So on the inside of the box, I have an x squared, so I wrote that down. And then I have a 3x and another 3x, so that gave me my 6x. And then I noticed that there's a lot of things that cancel. There's the xi and this negative xi. Here's this 3i and the negative 3i. This is negative I squared. So I squared is -1. Negative of -1 is 1. 9 plus 1 is 10. So when I multiply these two together, I get this trinomial right here. But it says I have to multiply this binomial by this trinomial. So get out another area model box. And now I have a binomial. and a trinomial. And I can just draw my area model however big it has to be to make me be able to multiply. So that times that. Just do the whole thing. 6x times x is 6x squared. 10 times x is x. These numbers inside here just came from multiplying. And then I'm going to go ahead and combine like terms if possible. So I see I have a x cubed. So that's where that came from. I see I have these two x squared terms. So 6 minus 4, that's where that came from. 24 and 10, actually it's a negative, negative 24. That gives me my negative 14. And there's negative 40. And that's actually the answer. That is the cubic that has these as the roots.